Hello, calculus fans. Let's let E be the first octant region. It'll be bounded by the planes x equals 0, y equals 0, z equals 2, and the surface z equals x squared plus y squared. And let's go ahead and compute the triple integral over E of x. The first thing we should do is see what the projection of the solid is into the xy plane. So if we intersect z equals 2 and the surface z equals x squared plus y squared, we'll get x squared plus y squared equals 2. That's a circle of radius 2 centered at the origin. Okay, looks like this. Remember, we're only dealing with the first octant region, so when we project, we get the quarter circle. Now when we compute an integral, we can say that the top bounding surface is z equals 2, and the bottom bounding surface is z equals x squared plus y squared. Alright, so here's what the integral looks like. The outer integral goes from 0 to root 2, that's the x. The inner integral goes from 0 to square root of 2 minus x squared, that's the y integral. Then the innermost integral goes from x squared to y squared to 2, that's the dz integral. And then what are we integrating? We're integrating x. If we evaluate that innermost integral, that inside turns into x times 2 minus x squared minus y squared. Now we're integrating with respect to y and x. And if we multiply things out, sort of looks like this. Alright, if we anti-differentiate with respect to y, then we'll get this. We'll need to plug in 0 and square root of 2 minus x squared. And if we plug in y, this is what we'll get. Now that looks messy, but it actually boils down into something quite nice. So we're going to integrate 0 to root 2 of 2/3 x times 2 minus x squared to the 3/2 power. We'll make a substitution to finish the integral. Here's the substitution we'll make. We'll substitute u for 2 minus x squared. So du is minus 2x dx. Change the limits of integration. We'll get 2 and 0. So after putting in everything with the substitution, we get the integral from 2 to 0 of 2/3 u to the 3/2 times minus 1/2 du. All right, let's clean this up. First of all, we don't like having the limits of integration be backwards, so we'll flip that around. That'll take care of this minus sign. And then we'll combine the fractions and clean it up. And here's what we get. 1/3 integral from 0 to 2 of u to the 3/2 du. And if we finish this up, we'll end up with 8 root 2 over 15. Okay, that's all for now.